Hi, this is Kyra, and as a continuation of last semester, we are going to start with another book section video. Today we are going to go over the section 11.1, which is sequences. Woo! Here's Patrick the Pig, and he's going to help us with our lesson. He is saying, let's get started, and I agree. Let's start with a few conceptual topics about sequences. Let's begin with what is a sequence. We are first going to start with a basic book definition. A sequence, as the book defines it, can be thought of as a list of numbers written in a definite order. And here's Patrick with a visual and what the list is usually supposed to look like. You will have a sub n, and the n stands for any number. So in the line, you will have a sub 1, a sub 2, a sub 3, and a is usually some sort of an equation. Some other notations may include an as an equation in the squiggle brackets. I'm sorry, I don't exactly know what they're called, but the squiggle brackets, you know. Or another type of notation would be a sub n, or the equation in the squiggle brackets, going to infinity, where n would start at a number, and in this case it starts at 1. Before we get into examples and theorems, there is some conceptual information that I would like to go over that I personally had trouble with when I was learning this section and this entire chapter of the book. So a common confusion is what's the difference between sequence versus series, and I thought it'd be a good idea to clear that up before we go any further into the lesson. Okay, let's do a quick comparison of the two. First note about the sequence. As we went over before, a sequence is a list of numbers in progression. But on the other hand, the series is the value of all of the terms in a sequence added together. Here comes Patrick to simplify the bullet point. They're also known as the sum or the value of the sequence. The next bullet point will have to do with notation. Revisiting the sequence notation, you have an, which is an equation. It's in the little squiggly lines. And then, series notation has the sum sign, which looks like an E, but it looks like a Z and an E, EZ, but it's the sum of the equation. Now that we have the basic conceptual information out of the way, I'm going to go through a basic example so you can see how the notation of a sequence might be set up, or how you might be asked to set up a sequence. Alright, here we go. Example number 1. We're going to work with basic notation. I pulled a really simple problem out of the book just so we can see how this works. I'm not going to go into anything too difficult, just so we can show how you may approach one of these problems. All sequences are a pattern, or they're some sort of pattern. And so when you're trying to find what the equation would be, you always want to look for what pattern is going on. So clearly, you can see that it's 1, 1/3, 1/5, 1/7, 1/9. So there's got to be something going on the bottom. So let's break it down. Let's see what A1, A2, A3, A4, A5. So once we break it down, we see that A sub 1 equals 1, A sub 2 equals 1/3, so on and so forth. In other words, you plug in 1, you get 1, you plug in 2, you get 1/3, you plug in 3, you get 1/5, so on and so forth. So now let's set up the equation. So looking at this pattern, we can see that 1 is fairly constant. So we can put 1 on the numerator. Now the denominator is the one that always changes. So how can you plug in 1 and still get 1 on the denominator? Plug in 2 and you get 3. Well, this is a fairly easy and simple pattern, and so we can go into depth on more different topics. We can just conclude that the answer will be 1 over 2n minus 1. You can check it. You plug in 2. You get 4 minus 1, which equals 3, so you get 1/3. Plug it in with the others, and you will see that the pattern works out perfectly. Okay, back to conceptual topics. With all sequences, you are trying to figure out if they are either convergent or if they are divergent. And of course, Patrick has to come in being all Hamlet, being all like, that is the question. But actually it is. In all sequences or series, you will be trying to figure out if it's either divergent or convergent. Okay, just a short recap. I know we learned this when we talked about integrals, but what is convergent or divergent? A sequence will converge or converges if it goes to a limit, or it is divergent or it will diverge if it either goes to infinity or the limit does not exist. All sequences are either convergent or divergent. Now to find which one it is, you will take the limit as n goes into infinity of a and n, which would equal L, and L is the limit. It can also be written as this. They both mean the exact same thing. Okay, let's quickly go into a theorem. So the limit as x approaches infinity of f of x equals some limit, and f of n equals a sub n at any integer, then the limit as n approaches infinity of a at n will equal the limit of f of x. And here's a graph to prove this theorem so you can see it visually. Okay, let's do a couple examples. So, example 1. I took number 26 out of the book, so here we have a sub n equals negative 1 to the nth power times n to the third over n to the third plus 2n squared plus 1. To attack this, you are trying to find the limit. So you'd have the limit as n approaches infinity to the an. For now, we can disregard the negative 1 because whether it's even or odd, it's either going to be negative 1 or 1, but either way, it's going to be some form of 1. Then we go on to find the limit as n approaches infinity, and we should remember our limit infinity rules. Here, the powers are the same, so all we have to pay attention to is the coefficients. The coefficient is 1, so the limit as n approaches a of n equals 1. But before you think it converges, it actually diverges because it's an alternating series. So whenever there's an odd number plugged in, it'll go to negative 1, while even will go to 1. Let's do another example. For this, I also chose another example from the book, so it's number 38, which is a sub n equals root n of 2 to the 1 plus 3n. To attack this, you can separate the 2, which it's the same as 2 times 2 to the 3n, and then you would distribute the n, or the 1 over n, and then you can simplify, which then you will get 2 to the 1 over n times 2 to the third. Simplified again, you will get 1 over infinity times 8. Which equals 1 times 8, so this is convergent to 8. Okay, one last quick concept note before I leave. You may be asked if a sequence is increasing, decreasing, or monotonic. It's pretty self-explanatory for increasing or decreasing, but monotonic means that it's neither increasing nor decreasing. It's kind of just goes all over the place. Another thing is bounding, so bounded above. That is when a sub n is less than or equal to m for all of n that is less than or equal to 1. And bounded below is just the opposite. The sequence is bounded if it is bounded above and below. I really hope my video helped, so thank you for watching. And repeating what Patrick says, good luck!